So today I'm going to show you an easy way to solve the lowest common ancestor problem in LeetCode. So basically you have a binary tree and we are given two nodes P and Q. We want to check, we want to find the ancestor that is common to both of them and also the lowest one. So basically if we have this P and Q, let's say for instance we have P is 2 and Q is 8 and Q is 8, we know that this is 2 and this is 8 and then the lowest common ancestor is 6. If we have some other things above, they are not they are common ancestor but they are not the lowest one, so we need to return the lowest one. So the methods I'm going to be using is called root shift. So basically you're going to be root shift method. That's the easiest way to solve it. So you're going to start from the root. You are going to check if actually this root is a common ancestor. If it is a common ancestor, for sure you are going to return it. But what you actually should check is that if both of them, so in this case we have 2 and 8, are less than 6. If both of them are less than 6, it means that we are now going to know that both of them are on the right subtree. Because remember, we are given binary tree, all right? And the question talks about binary search tree, if I can remember. So you have a binary search tree. So that take note that makes the whole difference. So it's not just a binary tree, but a binary search tree. So here, if both of them are less than 6, it means that both of them are on the same side. That means that most likely the lowest common ancestor is going to be here. However, if both of them are greater than 6, it means that both of them are on the right subtree, and then we are going to shift. So that's where the root shifts come from. We are going to shift the root from 6 to 8. But in the other way, we are going to shift the root from 6 to 8. So we are going to keep shifting the root. But if this does not hold, then it means that we found it and we are going to return the current node. So let's see how it plays out in code. So the first one we want to check, the roots actually should not be null because we are guaranteed that there's an ancestor for the two of them right there. So what we are going to check is while root. So let's say while root, because we are going to do it iteratively. We are going to say if p dot val is less than root and q dot val is less than root, we are simply going to second here. We are simply going to set the root. Root is equal to p is equal to root dot left. So in this case, we are simply shifting the search. We are shifting the search scope or the search region to the left subtree. So the other way around, if p dot val is actually p dot val is less than root and q dot val is, this time we are talking about, is greater than root, is greater than root, we are going to say root dot root is equal to root dot right. Okay, so at this point, if these two does not hold, actually we can say elif here. So we are going to say else. We already now found the ancestor. So we are going to break. Here because we found it, and we are going to simply return root. Yeah, I think I got it, but let's just see. Let me just cross check if then root dot less else if. Okay, so else break. Okay, perfect. So let's see. So let me run this code and let's see what we have. Run code and let's see. Okay, so so it's going to be the val here. Okay, the val dot val. Okay, so I'm going to run the code again and let's see what we have. Okay, so the same val. Okay, so run the code one more time. And this time it works. So let's go ahead to submit. Sorry, let's go ahead to submit the code. And you can see that it successfully passed runtime 80 milliseconds, faster than 66.31% of code submitted. So I'm going to be stopping here. I would like to thank you for viewing. Please remember to subscribe to my channel if this has been informative for you.